two major topics for today. One is the presentation of Chantico, and the other one is, again, the project lifecycle policy. And then a few things that are probably quickly discussed. Let's start with Chantico. So Chantico would like to join NeoNephos, and they are here today to present to the TAC what the project is about, how it's organized, and everything like that. So yeah, without further ado, I think I hand over and let you present.
All right. Thanks, Florian. Just give me a minute to introduce ourselves. That's me, Michiel, and Leon.
Hello.
Both at TNO, research organization in the Netherlands. We are with TNO part of a IPSCI-SIS project. And this project is about sustainable data centers. I will tell a bit about that in the presentation, but just to give you already a heads up, we're developing the Chantico software as part of that. So we want to show you what it is all about today. Also want to say thanks to Florian and John. I think John from Linux Foundation was in the call just before, for the support so far in this process, and looking forward to see how we can continue. Yes, so let's talk about Chantico, our energy-aware cloud-native controller. We have a few things on the menu. So first, Leon will talk about what it is about, what problem it tries to solve, and the approach. I will talk about who is behind it, so basically our project, our partners, and the outlook for development, how we think it fits into NeoNephos. We want to spend about 15 minutes on the first three topics and then have time for demo and also Q&A. So I think, Leon, the floor is yours.
Yes, thank you, Michiel. So indeed, I'll first talk about what is Chantico about, what kind of problem are you trying to solve with Chantico. Chantico is really about energy metrics, measuring how much energy is being used by various kinds of devices, resources, and services. A big problem in data center and cloud operations is to really manage how much energy you're using, how to monitor this, how to report this to various stakeholders, how to keep track of how much energy is coming into different sources, from green energy or battery or gray energy, how to provide this as attributed information to your different services you're providing, and how to reduce the energy that is being used in data centers. So these are all very difficult things to achieve because there's really a need to provide these measurements from the source that they're coming from, where the energy is being obtained, towards the services that are being provided to the customers. And this need for fine-grained end-to-end measurements is kind of hard to achieve when all the information is scattered around, is stored in different locations. So the idea is that the energy domain controller can help with this administration by automating a lot of the work that operator would otherwise have to do. So the idea is that Chantico is this energy domain controller. The name of Chantico is actually from Aztec religion. It means that it is the goddess of the fires that are being burned at the fireplace to heat up your house, which you cannot imagine currently, but is kind of relevant in some situations. And we thought it is a nice analogy towards having control over the energy flowing through a data center. And the idea is that Chantico takes minimal assumptions about what the operations are within the data center, that there's really a flexibility in how the resources are combined together, where a certain service might live. That it could also be migrating between different bare metal servers or Kubernetes clusters or virtual machines. So here we really want to keep track of all the information, but also be dynamic. And indeed, Chantico is not like a service orchestrator or something that does the workload shifting itself. Instead, it will communicate with one of those orchestrators, receive configurations, receive updates about resources that are in use, and reports on energy metrics. So on the next slide, we're showing a little bit on how we foresee the data coming in for this energy monitoring. So as you might know, servers have to get their power from somewhere. They're connected to power distribution units, and these are usually connected to several bare metal servers. And then upon these servers, you could either host platforms like VMs or Kubernetes pods, or you can resell these bare metal servers to your customer directly. So there are different kinds of resources that could then become services. So in this graph, we show that this is really like a layered setup, and data is coming in from the top all the way to the resources that can then be made available to a customer. Currently, you see that none of these are actually orange nodes, so they are not being sold as a service yet. But once you start doing that, you want to be able to track how much this service, this application, this customer is using. So on the right side, you could see that for each of these nodes, you can track the resource energy usage from the parent device or multiple parent devices when you're connected to multiple power distribution units or your cluster is running on multiple VMs. Then you can aggregate this information towards the resource node. And from there, you can start attributing this information towards a service. And you can see that there are different types of nodes, different types of resources. Turn the light back on. So you really get a lot of different kinds of nodes, but you do want to keep track of all this information such that the attribution can then be done properly. So that's the main idea about Chantico, and a little bit about the implementation after this. On the next slide is Chantico is currently being developed as a cloud-native application. We're really working towards keeping track of all the resources using a declarative approach. So you really use Kubernetes custom resource definitions for this. Really the cloud operator or orchestration framework or other automation tools will communicate with Chantico as the energy domain controller to indicate where all these resources are living, how to monitor them, and Chantico then provides back all the reporting for this. And we're really building this on top of other open source solutions that are already out there, such as Golang, Prometheus, but also Grafana and other long-term retention stores to keep track of all the metrics we're getting in. And the idea is that we keep on building on this to extend it further with other attribution and aggregation algorithms, and really remain agnostic towards the resources we are collecting to really allow talking to different platforms for VMs or Kubernetes clusters to still be able to do that. And finally, the Kubernetes controller is really the core of Chantico. We're building this using the typical frameworks to build this. And we're using very Kubernetes-based logic to keep track of the life cycle of these resources. So we track when they are created. We spawn some jobs to update configurations or other deployments. And we validate the resources that we get in. And once they are deleted, then we properly get rid of our resources again. Although sometimes you want to keep track of this information, so we have some long-term storage for the metrics as well. So this is kind of a quick overview of our current status of Chantico. At the end, we will also provide a demo of what we can currently show. But first, Michiel will talk a little bit more about the project as a whole.
Yeah, I will, unless there are, of course, burning questions. Then you can jump in now. Otherwise, I will continue.
I would be interested in a lot of things like, for example, P values, if they are calculated, and if you can calculate this down to maybe the amount of cores, or I don't know, how this decision is made so that I can say, for example, how much energy this thing is pulling. But since you're a demo, I keep my mouth shut till you show this.
Yeah, in general, those are things we want to do, indeed, down to the device and service level. So hopefully we can show something like that. We don't do the PUE calculations yet, but I think they should not be that far off, actually. Who is behind it? So what is the project that is developing Chantico? It's a bit broader than just TNO at the moment, although TNO is the party developing this software. The project itself has some other partners. My Zoom window is a little bit in the way. Yeah, so we're a 5-year project within the scope of IPSAI-SYS, as several other projects, of course. Also, I think in NeoNephos, we are together with our consortium about developing innovations for modular, integrated, sustainable data centers. In a nutshell, these data centers are small data centers. You could think about a container size, sea container size, where there is efficient cooling, for example, oil-based immersion. There is connections to heat grids. There is battery capacity in these containers. There is hopefully a connection also to green energy sources in the neighborhood. The idea is that these data centers allow operators to more easily fit into the infrastructure and its constraints. Currently, especially in the Netherlands, I also know in Germany, net congestion is a big issue. So you basically need to, if you want to build new infrastructure, it needs to be smaller and it needs to be more flexible and hopefully also more sustainable overall by giving back, for example, heat, but being more efficient as well. So that is what overall is the goal of our project. It runs for 5 years. We started in 2024. So we're in the 3rd year at the moment, about halfway actually, and have funding to continue until the end of 2028. Hopefully longer, but that's not something at the moment we can promise. We are always looking to extend these topics also from TNO's side because they are in our strategy. So we will keep looking for additional funding opportunities to also fund the development of Chantico. Let me just give you a little overview of the partners then. These are all Dutch companies that sort of banded together in a consortium to join IPSAI-SYS. We have 2 knowledge institutes, the University of Twente and TNO. We have a network and data center operator, Eurofiber, who we also see as one of sort of the early adopters of the software and a place where we can test. They have a so-called staging lab, which is a little data center where we can sort of test out our hardware and also software innovations. We have specialists about the data center engineering, Dearns. We have a cooling company, Aspiritas, that deliver these oil cool tanks. We have an application provider, Better Be, and we have the representative of the Dutch Internet and BIP that are mostly looking at the security of such small data centers connected together. TNO is the main developer of Chantico, the only developer at the moment. Obviously, by making things open source and running a project, we're hoping to expand that to maybe these partners, but also externally within and also outside of IPSAI-SYS to see if people would like to join that. A little bit, maybe a summary of the overall idea of the project. Again, we want to have these distributed micro data centers, as we call them, but then more of them. So we want to make also the data center compute capacity more redundant, while one thing that we're currently looking at a lot is sort of separating data from compute by having really fast, maybe all photonic networking between these locations so that we can be a lot more flexible with our compute. And for that, you need both to understand really where energy consumption is happening, but you also need to understand a lot about the grid and the local grid. So is there green energy available? Is there heat demand? Is there basically an incentive to run a workload somewhere? And all of these things are sort of in scope of the entire project. And we also want to build parts of those into Chantico and also other components coming in this domain that we will develop. that's some context on our project. And if there are any questions about that, this is a great time. I have to say, I'm not sure I'm still in the Zoom call, actually. Because
you are. We were just have been silent.
That is a relief. It's just that the call disappeared from my screen. Then I shall continue. How do we think it fits into NeoNephos? Well, some maybe obvious things, right? I think if we look at a NeoNephos portfolio currently on software, we think energy sustainability or sustainability in general might not be there yet. While there are a lot of projects going in that direction, I think Chantico is one of them. We think it sort of broadens the scope, and at the same time, also for us as a project, it's a benefit to be close to other infrastructure projects that are also looking at a cloud native approach, where more, let's say, direct collaboration could be initiated. Of course, we are within IPSI-SYS still and will be for a while, and the Aura initiative, as it's called there. So that is, of course, also where NeoNephos is coming from, and I think it would even strengthen the binding, or how do you say, the connections there. For us as a project, we are looking not to just develop this for ourselves and the direct people in our project, but we really want to increase the visibility of it, and also find others that might use it, or they might want to add to it, and sort of secure a longer term future for this type of software. Within our project, we have a clear vision of some use cases, but we also realize they might be specific to the operators we have. We want to find some places where more different kinds of use cases are available, and we think by generating visibility through NeoNephos, we can increase those opportunities. So in summary, I think community building for the long-term sustainability of this project, I think we're looking to take this step. We do have a logo. We are in discussion to create a new one, but we think it should reflect sort of the cloud native aspect of it. It's about infrastructure, and it is about sustainability. So I think it will be no problem. But thanks to Florian and SAP, I think, for offering some help on that aspect. This is all sort of available in our project proposal, but just for completeness, we've set up the project very much in line with the NeoNephos conditions. So we have a contribution guide. We ask first-time contributors to provide a developer certificate of origin. We have a code of conduct. We have a project charter. And these things are all adopted by our team. We're using the common licensing choices as well, Apache 2 and CC BY for the documentation. This is all visible on our GitHub community page, and so we think it's very much in line. Of course, if there are any comments or questions about that, we'd be happy to field those. And if not, then I think we will use the rest of the time for some demoing.
Yes.
Yeah.
So yes, a demo. Currently, we have a scenario where we can provision and construct a graph based on what we have in a normal data center, which is PDU, and then we can then add multiple PDUs as well as bare metal, which then demonstrates that we can aggregate the data from the PDUs that are being monitored into a large graph that will then be distributed to bare metal in this case. And later on, we will also augment this use case to also demonstrate that we can collect information from hypervisors and Kubernetes clusters that will report energy monitoring. And then we will be doing aggregation in a different way, where you actually are splitting up from a resource into the service that you provide to a customer. So first step would be to install Chantico. Actually, this is quite easy because you can then install Chantico using one of two commands, which are shown here. The first command is really for installing on a production cluster. It's really a simple one-line command where everything is packaged in a Helm package. So it's all deployed in one namespace currently. and then you receive Chantico as a core, but also a Prometheus, an SNMP exporter, long-term storage, and Grafana dashboard, as well as a file browser such that you can receive access to your volumes. So unfortunately, it doesn't seem like I can actually play the video from this, so I will instead share my screen to show that. So you should be able to see now that I will be writing some commands here. So to really make it possible to run this locally, we also have a few simple commands to start a kind cluster, which then sets up all the configuration for you, and then you're basically ready to go already. So we have some configurations to do port mapping such that we can actually see what we're doing afterwards, and also really have a local development that really looks like a production environment as well. So it's really easy to set up. You just also get the Helm package in there, but then it doesn't include the controller itself. Instead, it installs all the other components for you, as well as a mock device, which is a SNMP endpoint, which will provide us with random data when we query it with SNMP. And so that now it is running, we can actually see whether all the deployments are starting. So currently there are no data center resources yet, but the pods are starting. So you can see that we have a file browser, we have Grafana, a Prometheus instance, an SNMP exporter, an SP mock, and Victoria metrics for long-term storage. So they're all slowly starting, but once some things are running, then we can also start our controller locally. So this will provide us with the Chantico core controller, which will do all the reconciliation whenever a new resource comes in. I do have to set up my environment. Luckily, I have that all in N4C. So it checks whether I have all my environment variables set up. During a deployment, this is already inside the Helm package, but for now, I have to do that myself. Luckily, it's all documented what I have to do there, so I know what to do. So currently, the controller is now running. It's waiting for resources to reconcile. So in another terminal, I can then start fully get access to it. Be another user, because I was running this as another user, also to show that this also works when you're not the main user, as long as you have access to your Docker, either on WSL or Docker on Windows. This all works on local development. So now I can apply some files that will then perform the registration of some MIB files from SNMP configurations. I do have to also then provide first some files to it. So I'll be doing that first. I think I should instead share my entire screen rather than this window. We can get this out of the way and go to here. So there are actually two ways to provide some required files that we need, because in order to be able to monitor from SNMP devices, we have to upload something called MIB files. We have a thing that's called a make recipe to actually do this for us. That will just copy all the files into there, and then we already did it. The other way would be to drag and drop files into here. But now we have already done it, so that's fine. So we basically have done that, and then we can start applying certain files to do this for us. So we have to provide a physical measurement. I believe this one is already in there, so it's unchanged. So there are two files that we need to provide. One of them indicates how to measure SNMP devices, and the other one defines where they can be measured. So the physical measurement really indicates the IP address of the SNMP device, and the other one indicates how to walk through them. I can also display a little bit how they look like. So there is this file that indicates which walks we will do on the SNMP device. So these are usually coming from the MIP file, indicating how to monitor, for example, the output power of a PDU, which is a specific field that you can obtain via SNMP. So we all just define this in our resources. And similarly, for the physical measurement, this has already been configured to look at this host name. So this is currently running inside the cluster, but in a production environment, you would then provide the IP address of your PDU or your bare metal SNMP interface. And then this has all been set up now. We can then verify that it has been registered by going to Prometheus, which has also been deployed through this way. We can then see that there is now already a target endpoint here, which has been discovered via service discovery. And we can actually already monitor information from it. So we can see information coming in from it. Then before we round up this demo, I will also indicate how you can then combine this information to demonstrate what it will be to measure from bare metals. So for this, we will first deploy a few more services. We have now one mock SNMP interface, and we actually want to have two of them to pretend we have two PDUs, so that we can start monitoring the second one as well. So these basically does this basically add another pod that's running here. We have two mocks here running, and these have endpoints that we can collect this random data from. So then to configure the controller to actually do its monitoring work for this, we also have to add these files to it again. And as well for a measurement device. Basically, you wouldn't need a second measurement device because they're basically the same brand, but currently we're just providing a second one just to demonstrate that this will all be working. And in the background, the controller is just updating, generating configuration files, updating deployments, performing exports, such that it will all be handled and put into Prometheus. So now we can see that there are two endpoints here. And to finally get them together, we use a file that is called data center resource. I'll just first show what it looks like. So it has basically a number of resources that we then provide to our controller, which first gets validated before it actually gets used, because there might be errors in this graph, there might be loops or dead ends. We do want to make sure that all our energy is still accounted for, or that we do not generate infinite energy by looping it back into each other. So we will be deploying this and checking if the validation has succeeded. So we'll have a look. Unfortunately, it mentions that there's a cyclic loop detected. And now the question is, where did this happen? We see that PDU1 is fine. It doesn't supply any error messages, but PDU2 does have some errors. So we'll look back into the file and we see that the PDU2 has a parent to the bare metal, which doesn't make sense. Instead, the bare metal should have parents to PDUs. So we fix this and we apply the file again. So it detects whether some of them has been reconfigured, some of them have not been changed. But when we then check if any issues are still there, this has been fixed. And we also find that the other resource is now also fully configured. And when we go to Prometheus, we still have these targets, but now we also have a few rules that indicate that these have to be aggregated together into a bare metal machine that we can then also collect data from. Then we get this metric, which will start aggregating both of the other two that we had. And basically, this will then also end up in Grafana interface, which is also supplied within this deployment, where we can then see information about each PDU coming in with all the data. It's currently a very fresh deployment, so we don't see that much. So that is what you then currently receive as a customer, a good overview of where all the data is coming from. So I think that is basically it for our demonstration. I can probably now go back to the presentation again, although there's not much more to mention there. So are there any questions in the meantime?
I would have some questions. I see now that you collect the data mainly with SMP. Do you use also other, or how difficult is it to use other resources like directly from Redfish or like directly from IPMI? I mean, both supply power ideas from bare metal systems.
Yes, that's very true, very correct. We have also indeed investigated using IPMI as a resource to retrieve data from, and it is indeed possible. We've also configured this and used an IPMI exporter for this, and it has worked. We have noticed that it is slower to obtain these measurements via IPMI, and there is a larger window that you obtain then for these metrics. We really want to obtain our data in the highest resolution possible. That's also why indeed we have looked into monitoring from bare metals directly, because sometimes some PDUs do not provide the resolution that we need. They only provide information in sizes of 10 watts instead of what we would want every single watt count.
That would be exactly more or less the next question, because when I take a look, for example, to bare metal machines, they report some amperes, some watts or volts, watts, whatever together, but what we figured out, it is not very accurate. Because the problem is, it seems that that the measurement units, which are usually some kind of resistors, are not very well adjusted. Is there a possibility that you can, for example, see in a PDU, because the PDU normally is pretty much adjusted because you pay money for that, in the server you get it for free, that you say, oh, we have here a PDU, that PDU does sees, I don't know, 5,000 watts, and we have 5 servers behind, and each of them sees 1,200 watts. Can you do some correction values? Is that a plan, so that you can say, hey, this machine has a problem of, I don't know, 0.8% or 0.8 or whatnot?
Indeed, this is our plan to do this. We believe that there might be some overhead that is not being accounted for when you monitor between the PDU and the PSU, the power supply unit of a bare metal. That not all the energy that is coming into the bare metal is actually usable for customer applications. So there will be some overhead that we either have to account for separately. And we have indeed also monitored bare metals with SNMP. Some of the IPMI interfaces also support SNMP. And here we do receive some more fine-grained information, very specific information about how much energy is being used. And in this case, we want to indeed see what the difference is with the PDU monitoring, and then use this overhead either for like a separate reporting of overhead or a redistribution over the workloads that are running on a bare metal.
Okay, and I mean, I saw you have in your presentation, for example, monitoring storage. I mean, that's rather linear. Yeah, you say the storage, I don't know, burns 3,000 watts, and you have I don't know, three petabyte of storage there. Then you know exactly how much watt each petabyte eats, or how you can distribute this. But if you have a server, I mean, the server has RAM, which burns energy, and you have CPUs that burn energy. What would be then your calculation strategy? Because that is not quite linear. Yeah. So what is then the focus calculation point, or I don't know how to describe it.
Yes, our plan for calculating like resource usage on a bare metal itself, so by applications or VMs or pods, is really to defer this to applications that are able to do this non-linear calculation, to not just assume that a VM has access to a certain number of vCPUs or a certain fraction of RAM, that it will always be using that much, or that when we see in the process information that it's using a certain percentage, that this percentage is truly what is being used. Okay. So we will use existing open tooling, such as Kepler or other RAPL-based information, to help with extracting this information for us, and also perform our own aggregation algorithms on top of this.
And I think it's important to understand that we still work with sort of the energy consumption being reported at the lowest level, so from the PDUs. We want to allocate it all the way upwards. However we allocate it, we always want to have all the energy sort of accounted for. So things like RAPL are known to just report on a piece of the puzzle, but not on the entire thing. So we want to be sure that we can always add up to 100% of everything that was consumed.
Thanks a lot.
All right. Hey. Are there more questions? Sounds like it. Thank you very much for the presentation. Very interesting. So the next step would be I will start a discussion on the TAC mailing list. We will do a vote at some point, and then we will let you know where you ended up.
Okay.
Right.
And then you would be invited to one of the next TAC meetings for normal contributions. Thank you very much.
Okay, welcome. Thanks a lot for your attention, and we'll be waiting by the phone.